So in this video, we're going to continue and speak about sets. Namely, we're going to talk about operations on sets. So the first operation, so operations on sets. Pardon my handwriting. At nature, or my training or my background is mathematics and physics. So all I accustom is writing maths and physics. So when I tend to write out normal words, it tend to be very scrappy, but legible enough. Operations on set. So the first operation that is of importance is A union B. So this is the element such that X is an element of E or X is an element of B. Again, I don't know what is wrong with my brain when it comes to this right hand curly bracket. For some reason, this can't try properly. Now, the next operation is A intersect B. This is the element such that X is an element of E and X is an element of B. Now we have a complement. A complement is a set such that X is not an element of E. So it's everything but elements of E. Now, one thing to point out, when you operate or you do these operations on sets, your result is another set. I would illustrate that just now. So we have the union, the intersection, the complement. Am I missing anything for CSEC? Math and ADDMATHS here. We have the empty set, which is the set that has no elements. I think about this like the set equivalent of 0, like how 0 is like nothing. The empty set of phi is like the set equivalent of 0. Now, there's some useful properties to know about the empty set, meaning the empty set is a element of any set E. So the empty set is an element of any set, is a property of sets. I'm gonna keep this video simple because if I start to delve into sets, we would be here for an hour, like deep into sets. But these is the important properties that we need to know for math and ADDMATHS. And there is something called the singleton, or so let me write this out. So singleton, sorry. Singleton of a set E. The singleton is as a set. Singleton is a set that has only one element. So let's use Venn diagrams now to illustrate what these things really mean. So if I say A is equals to 1, 3, 5, 7, 9, and B is equals to 3, 6, 9, 12. So A union B would be as follows. From set A. So the union is basically where there's an overlap, meaning there's some element in common. So look at this here. So there's an overlap. So 3 and 9 would be here. Then if this is A, 1, 5, 7. If this is B, we have 6 and 12. So B is a set 3, 6, 9, 12. A is a set 1, 3, 5, 7, 9. But there's an overlap. This is the union. So A union B is equal to the set 3, 9. No. A union B is equal to the set, 3, 9, 6, 15, 7. Yeah. 7, 1. So the union is when X belongs to A or X belongs to B. So is really this. I made a slip of the tongue when I mentioned the overlap. The overlap is actually the intersection. So A union B is all the elements of A or B. So we have 1, 3, I miss out 5. Let's scrap this. A union B is equals to 1, 3, 5, 6, 9, 12. One, 3, 5, 6, 7, 12. 1, 3, 5, 6, 7, 12. 1, 3, 5, 6. Forgot the 7. So 1, 3, 5, 6, 7, 9, 12. So A union B is this set. So the cardinality now, this is the symbol of cardinality. That's these two lines, is how much elements? 1, 2, 3, 4, 5, 6, 7. Let's count this to verify. 1, 2, 3, 4, 5, 6, 7, 7. Now the overlap here is A intersect B, meaning X is an element of E and B. So 3 and 9. So the cardinality of A intersect B is 2, meaning the elements in the set, the number of elements in the set. So the union is represented as generally as for two sets A and B, you have everything in A and B. And the intersection so the union U, not U, but this is the symbol for union, and the intersection is represented as, remember, Venn diagram is diagram used to represent sets. E, if this is E, this is B, the intersection is that. Now the complement of E, so the complement of E, so given two sets A and B, this is B, this is E, is everything but E. So it would be this bits here and these bits outside, whatever is outside. That is the complement of E. So these Venn diagram represents the operations, so the basic operations on sets. There are other operations on sets, but for CSEC, math and ADDMATHS and math up to if you is age 15 or 16, this would be sufficient. So in the next video, we would be discussing coordinate geometry, some more coordinate geometry. If you like the content, please subscribe. If you don't, just thanks for watching still.